In this lesson, we're going to identify mixtures as homogeneous or heterogeneous. Now looking at the other side of our flowchart, we're looking at mixtures, and we can divide mixtures further into homogeneous and heterogeneous mixtures. When we look at the prefix homo, we remember that it means same, and the prefix hetero means different. So when we look at a mixture, we're looking whether it's the same throughout or different throughout. Let's look at some examples here with these diagrams. What we see on the left side is a homogeneous mixture. And so it's the same throughout. No matter where I would take a sample from, I see exactly the same thing. When I look at the heterogeneous mixture, if I look at different parts of the sample, for example, at the top and at the bottom, I see something different. Therefore, we have a heterogeneous mixture because there are some differences throughout the sample. So just a reminder, compounds contain two or more elements bonded together in a fixed ratio, while a mixture is a combination of two or more pure substances that are not chemically bonded together, and they can have a variable ratio of substances. The example you see here is sulfur powder with iron shavings in it. And we could have any combination of those two amounts, and it would still be a mixture. They do not react chemically, they do not form a new compound, they're just combined together. And they can be separated as well. So a mixture is combined but not reacted. When we're looking at mixtures, we're not forming compounds. We're looking at both substances retaining their identity in the shared container. A balloon contains H2 and O2 molecules. Is this a mixture or a compound? So if we zoomed in at the molecular level, what we would see is H2 molecules and O2 molecules. Remember, both of those elements exist as diatomics in nature. So we see lots of H2s and O2s, and there's no reaction occurring. The H2s and O2s are separate from one another. They're not reacting, and as a result, we see that this is in fact a mixture. Now a balloon containing H2O molecules, is this a mixture or a compound? In this case, we have H2O molecules because that compound has formed. Just because two elements or two substances are combined doesn't necessarily mean they'll react. And there's a lot more information we need to know to predict the reaction. So at this point, we're just saying there is water in the balloon. These are all present as H2O molecules. Therefore, this is a compound, not a mixture, because it's just H2O molecules. Let's look at some examples of homogeneous mixtures. Remember, homo is the same throughout. So if we look at milk, and we're talking about the milk that you would get at the grocery store, remember the label on that says homogenized. Okay, so it's the same throughout. Steel in a bridge is a mixture of different metals, and that's going to be the same throughout. You're not going to have one metal here and another metal there. It's completely mixed. The neon in lights is not just neon. There are other elements added to change the colors of those neon lights, and so those are going to be homogeneous mixtures. And then aqueous solutions. So if I dissolved a compound in water and it completely dissolved, then we'd be dealing with a homogeneous mixture. For heterogeneous mixtures, smog is one because you'll see different particulate levels at different spots in a city, for example. If you have raw milk from a cow, so if you had raw milk from a cow and you let it sit, you'll actually see it divide into the different layers and the different parts of the milk. So that would be a heterogeneous mixture. Dirt, rock, gravel on the ground, also heterogeneous because every time I took a sample, I would get something slightly different. And blood is also a heterogeneous mixture. So if you let blood stand, you'll start to see the different particles and different things in your blood settle into different layers. How do we identify these in a practical sense when we're looking at a sample? Let's look at the mixture on the left. If I were to take samples from this mixture at the top, middle, and bottom, what I would see is exactly the same thing throughout. All of my samples would look identical to one another. And that's a clue that we're dealing with a homogeneous mixture. Contrast that to a heterogeneous mixture. If I took samples from the top, middle, and bottom of my mixture, what I would see is something different. At the top, I'm just seeing water. In the middle, I'm going to start to see some sand and some water. And at the bottom, I'm going to see mostly sand and only a little bit of water. So there's something different there. And as a result, that gives us a heterogeneous mixture. Is this, the bowl of cereal, a heterogeneous or homogeneous mixture? This would be a heterogeneous mixture. Depending on where I took the sample from, I'm going to get a different mix of cereal and milk. If we look at the very bottom of the bowl, chances are it's going to be mainly milk. As we move to the top, we'll get more cereal, and it's going to look different. So we have a heterogeneous mixture. Is this a heterogeneous or homogeneous mixture? So we have a bottle of Italian salad dressing. This would also be a heterogeneous mixture. If I look at the sample at the bottom, middle, and top, I'm going to see different things because in Italian dressing, you have oil and water mixed, which don't like to mix. And so before you pour this on your salad, you shake it up so that you get an even distribution. But it is a heterogeneous mixture because it's not the same throughout. Is this a heterogeneous or homogeneous mixture? This is a homogeneous mixture. It is an aqueous solution, which just means it's something dissolved in water. All that means. And if I look and took samples from the top, middle, and bottom of this mixture, what I would see is at the molecular level, they would look exactly the same. And therefore, this will be a homogeneous mixture.